In this video, let's talk about 5D. Is it actually possible for us to make a 5-dimensional game? And if it is possible, what would it even look like?
Let's go.
The letter D stands for the word dimension, which means an axis or a direction of measurement. These are the exact same ones they teach you in school, the x-axis and the y-axis, where each one represents a single dimension. The x-axis represents width and the y-axis represents length. Video games use dimensions to represent objects, ranging all the way from 1D to 3D. Let's break them down, starting with the simplest one. 1D means you are using just one dimension or axis, either the x-axis where you only use width or the y-axis where you only use length. An example of a 1D game is something like Line Wobbler. In 2D, we use both dimensions or axes together, the x and the y, representing both length and width. This is the opposite of 1D, where you are strictly limited to just one dimension. Some of the most famous 2D games out there are Hollow Knight and Celeste. Then comes 3D. In 3D, we add an extra dimension on top of length and width, which is height, or as some people call it, depth. This gives the illusion that an object is physically real. Some of the most famous 3D games include titles like GTA and Call of Duty. Now 4D. The fourth dimension is a point of disagreement between the two biggest theories in physics, string theory by Gabriele Veneziano and the theory of relativity by Albert Einstein. Each one explains the fourth dimension in a completely different way. For instance, the theory of relativity states that there is no such thing as separate space and separate time. Instead, the two are woven together into a single fabric called space-time. Space-time consists of 4 dimensions: length, width, height, and time as the fourth dimension. So, according to relativity, the fourth dimension is actually time. On the other side, string theory states that the universe is made up of the vibrations of microscopic particles that are much smaller than an atom. These vibrations are what actually create the components of an atom: electrons, protons, and neutrons. For this theory to make mathematical sense and to give these particles a way to vibrate, there must be more mathematical dimensions than just length, width, and height. According to string theory, the fourth dimension is a physical dimension that takes up actual space in the universe, just like length and width do. It's just that humans cannot perceive it. Scientists created a visual representation of a 4-dimensional cube and named it the Tesseract. It's that strange looping shape that always pops up whenever 4D is mentioned. If you want to know more about 4D, there is a game called 4D Toys by a developer named Mark ten Bosch that simulates how 4D shapes would interact in a 3D world. So if you're interested, you should definitely check it out. A quick note for those interested, there is also a very famous game in this field called Miega Kude. It is a puzzle game that relies entirely on moving through the fourth dimension to solve puzzles that seem absolutely impossible in our 3-dimensional world. It is an excellent realization of how we would interact with 4D. We can actually make a 4D game based on either of the two theories, whether it's relativity or string theory. But the real question is it possible to make a 5D or even a 6D game? First, let's look at how the two major theories interpret 5D. According to Einstein's relativity, there is no such thing as 5D. However, string theory states that there are dimensions higher than 4D, reaching all the way up to 11D. But even if we assume that a 5D or 5-dimensional object exists, there isn't as much information available about it compared to 4D. For example, if I asked you what a 4D cube looks like, you would most likely know it's a tesseract. But if I asked you what a 5D cube looks like, you probably wouldn't have any idea. However, there is a simple method we can use to form a conceptual image of 5D. The rule is that every corner of a shape in a higher dimension represents that same shape in the dimension right below it. For example, take the 4D cube, the Tesseract. Its corner, or boundary, consists of 3D cubes. A 3D cube's boundary consists of 2D squares. A 2D square's boundary consists of 1D lines. And a 1D line's boundary consists of a 0D point. The reverse is also true. Every shape in a lower dimension forms the building block for the shape in the dimension above it. If we follow this mathematical law, it means a 5D shape would be made up of 4D corners, which are tesseracts. If we replicate this structure, the shape we get is called a Penract, which is the conceptual model of a 5-dimensional cube. We can use this exact same rule to construct a 6-dimensional shape by building it out of a collection of 5-dimensional shapes, which gives us this structure, the Hexeract. All of these shapes are purely mathematical and conceptual because, as we mentioned, it is physically impossible for a human being to perceive any dimension higher than 3D in reality. So you might ask, how could a 5D or 6D game even look according to string theory, given that we can't actually see any of these shapes? The solution lies in perspective. It is true that we cannot view these shapes in their entirety, but we can see their cross-sections or their effects on a 3D world. Let me explain this with an example. If we take a three-dimensional object and make it pass through a two-dimensional world, from a 3D perspective, we just see the object easily passing through a flat plane. But from a 2D perspective, you would see an object suddenly appear out of nowhere, grow bigger and bigger, and then start shrinking until it completely vanishes back into nothingness. This happens because a 2D space cannot represent a 3D object fully. It can only display a slice of it at a time. If we apply this exact same principle, we can also observe a four-dimensional shape inside a three-dimensional world. For example, in the game 4D Toys, we see how four-dimensional shapes would look and interact in a standard 3D world. Or take the 4D version of Minecraft made by a YouTuber, which uses perspective to simulate movement in the fourth dimension. It works by allowing the player to shift or rotate their perspective along the fourth dimension. Doing this allows them to see things they couldn't see from their original position in 4D space. Even entirely different monsters that you can't lay eyes on unless you shift your perspective into the fourth dimension. So if we wanted to make a 5D game, we could use this exact same concept of shifting the player's perspective. Since a 4D game uses one horizontal axis to represent changes in the fourth dimension, we could instead use two axes to shift the perspective. The first axis would change horizontally to represent shifting through the fourth dimension, and the second axis would change vertically to represent shifting through the fifth dimension. At this point, you might be thinking, oh wow, we can finally make and try a 5D game. But unfortunately, no. When games surpass 4 dimensions, they become complicated in a thoroughly obnoxious way that makes them fundamentally unplayable. So while we can absolutely create them theoretically, I don't think anyone will ever develop a full 5D game. It is just way too complex, and it wouldn't appeal to a large audience of players. Thanks for watching, and see you all soon.